Welcome to the machine learning demo in the AppVisualize tool. Machine learning is also often referred to as predictive analytics or predictive modeling. At its most basic, machine learning uses programmed algorithms that receive and analyze input data to predict the output values within an acceptable range. As new data is fed to these algorithms, they learn and optimize their operations to improve performance, developing intelligence over time. There are two types of machine learning algorithms implemented in our product: supervised and unsupervised. Before going into that, we need the data to do analysis and prediction, where the operator provides the machine learning algorithm with a known dataset that includes desired inputs and outputs. So we need to create a connection by defining the database information. In order to create a connection, choose the connection icon from the App Connect tool. These are the available endpoints in our product. We need to choose a connection where the actual data is stored. This is the connection creation page. Here we need to provide valid database information in order to create this connection. After all the information is provided, we need to save the connection. Once the connection is created, we need to define this connection by creating a data lake. To create a data lake, click the data lake icon. We need to define the connection which we created earlier. Once it is done, we need to save the data lake. Then, we need to create a dataset under the defined data lake. To create a dataset, press the dataset icon. This is the creation page, where we need to provide the required information and choose the table where the actual data is stored. After choosing the table name, we need to go to the next page where we define the dimension and KPI column. After all these setups are done, now we are ready to do prediction with the available algorithms. As stated earlier, there are two types of machine learning techniques implemented in our product: supervised and unsupervised learning. First, we'll discuss supervised learning. This is the landing page for supervised learning models. In order to create a supervised learning model, we need to click the plus icon. This is the supervised learning model creation page. Under supervised learning, there are two categories: regression and classification. In regression tasks, the machine learning program must estimate and understand the relationships among variables. Regression analysis focuses on one dependent variable and a series of other changing variables, making it particularly useful in prediction and forecasting. In simpler words, through the regression analysis, the numeric values can be predicted. These are the available regression methods: linear, multilinear, ridge, lasso, elastic net, logistic, time series, support vector machine, decision tree, and random forest. In classification tasks, the machine learning program must draw a conclusion from observed values and determine to which category new observations belong. For example, when filtering emails as spam or not spam, the program must look at existing observational data and filter the emails accordingly. In simpler words, through the classification algorithms, the categorical values will be predicted. These are the available methods in classification: naive Bayes, k-nearest neighbors, support vector machine, decision tree, and random forest. The supervised learning models are performed with the data fetch model, known as sampling. This is the process done in order to find the strength of the test data. Some available data sampling methods are random sampling, top, bottom, and full. Once the required information is given, we need to map the predictor variables and response variables. Then, we need to save it and build it. After the model is built, the model summary for the train data will be displayed, and also, we show the plot images of the train data. Then we need to execute it by providing the proper inputs needed for prediction. The input files can be uploaded as CSV files. Based on the input, the prediction has been done, and the results are also available in a table view. These are the predicted values. With the provided information about these attributes, the horsepower has been predicted. Since it's a regression model, it predicts the numeric value. Similarly, the classification algorithms are executed in the same way. Based on our input, the prediction is done. These reports can be exported as CSV files. Now, on to unsupervised learning. Unsupervised learning is achieved by k-means clustering algorithms. Normally, the clustering involves grouping sets of similar data based on defined criteria. It's useful for segmenting data into several groups and performing analysis on each dataset to find patterns. To perform the k-means clustering, we need to choose the dataset. And then select the columns that are required for this analysis. Once the columns are selected, we need to provide the cluster name, number of clusters, and common KPI name. After the setup is done, we need to execute it. Based on the data provided, the data has been clustered into 3 categories. This information can be visualized through interactive charts. These are the cluster representation charts. Here we're able to see the count information of each cluster. In cluster 1, there are 12 counts. In cluster 3, there is 1 count. In cluster 2, there are 5 counts. We can also get more information through cluster dimension distribution, where it will show the detailed information of each cluster. Here's the information for cluster 1, cluster 2, and cluster 3. In addition to that, we are able to view the overview information about the clusters. That's all about unsupervised learning.